Okay, so yeah, we're going to get going. So it's 2:40. So we got a few people in. Like I said, this is not required to be here. Just um, for those who aren't here, you need to watch this by Friday. So let me just switch over and get my desktop here going. Yeah, I tell you, before we get going, does anybody have any questions, comments, concerns? Everybody doing okay? Okay. So hopefully you'll see my desktop, which is
So they're eating out here, or in there, or in here?
what was that? Ah. Okay, if nobody has any questions, so what I've got is that we've got two sections of 2720. So I've just got section one, but section two is pretty much the same in there. So here's the Zoom login information. When we're done, I'm going to take this recording and I'll upload it on YouTube. Hopefully it won't take too long to upload for that. But like I said before, and I guess last week was pretty iffy on some of the audio and technical. I think we're stretching YouTube to its limits.
Anybody hear me?
Yeah, we can hear you. Okay.
Oh my God, Mike.
And so anyway, so I'm going to try this on Zoom to see, how it'll work, if it'll work any better. But hopefully you guys are seeing my desktop right now, I hope. Any takers?
Yep, looking good. I'm just trying to figure out how to make it not full screen anymore so I can put it on a different monitor.
Oh, good luck on that one. So anyway, you notice, and I'm going to cover this again in the announcements. So quiz 3, which is over propulsion. So what we're going to talk about today is electronic speed controls, and that is the last section of propulsions for this. But anyway, quiz 3 will open at noon tomorrow and will close at basically 11:59, the end of the day on Friday. So there'll be some more information. I'll put it out tomorrow. Pretty much it's D2L. Since it's open book, you can, you just get one shot at it. So if there's any questions, let me know. So let me go ahead and bring up the PowerPoint for today. And let's see. So what we're going to talk about is electronic speed controls, ESCs. So there's some videos in the section that talk about this and give a little bit more detail. But this is kind of the last link on the propulsion section. So, but before we get going, I just want to make sure everybody is doing okay. Nobody's stressed out because of the coronavirus, and hopefully you're keeping up with your classwork. If you're having any issues, go ahead and send me an email. I have my MT mail, and I'll try to help you out the best I can. Everybody got enough toilet paper? That's one thing that's amazing me is the shortage of toilet paper in the United States. But make sure you're hanging in there. This is what, week 12. We're going to week basically 15, but it's only half a week in there. So we're almost to the end. So you guys have probably been bombarded by emails from either the administration or Dr. Beckman or various people on that. So summer and fall registration open Monday. So if check your email to see when your registration time is. So I guess it's the early registrations are going on now for both the summer and the fall. So keep an eye on that. And I think everybody knows that there's no on-campus classes this summer. So they're either going to be remote, which you guys are going through now, or it's an online course. And really the only difference is an online course was previously approved to be online, where a remote class is typically a face-to-face class that they're going to deliver either somehow or some way through D2L again. So if it was a face-to-face class that was scheduled, it should not show up in the summer schedule at all. So good example, I don't think we have any seniors here, but like 4040 is the aerospace capstone. And that class will, you shouldn't even be able to see it to even register it. Okay. And like I said, is quiz 3 and propulsion opens at noon tomorrow, and there'll be an announcement and email that comes out on D2L. And you've got till Friday, basically the end of the day to get it done. All right. Anybody got questions on any of that? Okay, nothing heard. So kind of in the news, this came out. I mentioned it to another group, and I can't remember if I told this group last week, but the FAA Knowledge Testing Centers are actually contract centers. And so they're run by a company, can't remember if it's CTI or something in there. I can't remember what they contract training or something in there. But like the one in Murfreesboro at Murfreesboro Airport is administered by Murfreesboro Aviation, but it's contract through this. But they have the option whether they're going to stay open or not. For those who know Doug Campbell, who's our UAS operations manager, last Friday he had to take an exam, and the closest knowledge testing center he found was down in Huntsville, Alabama. So they are still open. So if you decide that you're going to try to get your Part 107 this summer, or if you're going to try to do your requalification, which is every 24 calendar months, you're going to have to see if you can find a center that's voluntary staying open to do that. So if you can't get your 107, or you can't get your requalification that's required every 24 months. In my case, mine expires next month at the end of May. If I can't get it into a testing center, is legally I cannot fly under Part 107. So the FAA supposedly is working on fixing this. Well, let me put it this way: they're aware of the issue, so I'm not sure what they're going to come up with. So if you were planning to get your 107 and do some work this summer, you may be out of luck for a while. Okay. So what we're going to do is talk about electronic speed control. So, we looked at batteries. So a battery will plug in either to electronic speed control or what they call a power distribution board, or PBD. And then from that power distribution board, it goes into electronic speed control, and the electronic speed control goes into a motor. So if you guys remember what kind of power output or what type of power does a battery put out, and since nobody can respond, is it will put out a direct current or DC power. Now, depending on how many cells it is, and remember, the rule is for every cell is approximately the nominal voltage is 3.7 volts. And there is DC power is that electronic speed control fulfills two purposes. One is it will take that DC power and convert it into alternating current. Okay, so on a brushless motor, and which is the kind we were talking about the other day, on a brushless motor, those are three-phase alternating currents. So on a ESC, we'll take that 12 volts, approximately 12 volts DC, and we'll convert it into 12 volts alternating current. And that's why on an ESC, in this example, you'll see two wires coming in, a positive and negative, and then three wires coming out. So it takes that 12 volt DC and converts it into alternating current. So hopefully that will make sense. Okay. The other thing that it does is it's also the speed controller for the motor. So when I make an input on my throttle, okay, on my transmitter, when I basically move that transmitter sends a signal to the receiver on the aircraft and says, okay, I want half power. It either goes into the flight computer or it goes right into the ESC, and I will get the corresponding power to that ESC. Hang on a minute. Excuse me. So in other words, if my throttle is at idle, so I'm taking that 12.6 volts at approximately 12 volts of DC current turning to AC current. If it's not regulated, it's just going to run that thing at the full voltage. So what the ESC does is, besides converting the power from DC to AC, also lets us control basically the flow of power to that throttle. So, and that's why typically when I show it a little bit later on, you'll see some wires coming off that plug in either to your flight controller or right into the receiver. Okay. Now, the other thing you'll see on this diagram, if you can, in kind of lower left above the servos, is what they call a UBEC. And a BEC stands for Battery Eliminator Circuit. Now, ESCs can either have a BEC embedded in them, or you have to run a BEC separate. And if you remember, an ESC takes DC power, converts it into AC power, or a BEC will take DC power and regulate it down to 5 volts DC. Okay, so it doesn't convert the power, it just is it reduces the power. And the reason it goes down to 5 volts is you'll find that your receivers and your servos and a lot of other equipment on your aircraft all take 5 volts of power. So if I hooked up my receiver straight into a power distribution board or straight into my battery, we would probably blow it up because it can't handle that 12 volts. We need some way to bring it down through a battery eliminator circuit, either built into the ESC or separate down to 5 volts, if that makes sense to everybody. Okay. The other thing you'll find out is sometimes in these electronic speed controls will handle everything from a 2-cell battery all the way up to a 6-cell battery. So it's very important that we take whatever that voltage is and get it down to that 5 volts. So here's an example of somebody who has one set up for a fixed wing aircraft, and basically 2 power plants in there. So it runs two ESCs. So it will take an input anywhere from 2 to 8 cells on a LiPo battery and transfer that power to ESCs and then through the UBEC down to 5 volts. Okay, kind of looking at a multi-rotor. So kind of the same, the same principle. So this is a CC3D board. This is the first board that you'll build in the box quad. But if we kind of follow the path from left to right, is we will have a transmitter, which will send a signal from our transmitters, and we'll talk about that here in a couple of weeks, to the receiver. And that receiver takes those inputs and sends those inputs into, in this case, is a CC3D board, which is kind of like a mini autopilot. It's got some basic algorithms that will help it for stability. On the CC3D, it's also expandable, where we can put a GPS and we can put telemetry links in it. So you can actually expand this out and put cameras on it. But then you notice on the far right side is the battery there. In this case, they run it through a voltage and current sensor. And so the reason they do that is it can actually take that information, send it to whatever my flight controller is, so I can get a readout of my battery power. Okay. So either on my computer or if my transmitter is set up, so as my battery starts to drain, I can keep an eye on that voltage. And then the main power of the battery, so if we're using a 3-cell battery, a 3S battery, so fully charged is about 12.5, 12.6 volts, goes into that power distribution board, that little square there. And so it goes in, and then if you look at that power distribution board, there's 4 pads. So this one is actually set up for a quad rotor. And so each pad, we will tie in our ESC. So I've got 12.6 volts going in from the battery, and it will tap off and get some voltage current sense, and then it's going to put that 12.6 volts into this power distribution board. And then this power distribution board allows other users, in this case, it's going to be the electronic speed controls, okay, to take that DC powering and convert it to AC power. Okay. And then if you look, coming off of each ESC, is you'll see 2 wires. In most cases, it's actually 3 wires. So you'll see the typical red, black, and kind of an orange wire, or red, black, and white, depending on who makes it. But that is our signal wires. And if it's a BEC, that also supplies the power back into the electronic speed control. But so when I make that input into my transmitter, so I said, okay, I want to take off. I move my throttle up to about 75% or whatever it takes. That signal is received by the receiver. Okay, it says, all right, we want to take off. And through whatever circuitry this has, and then it will send to all 4 motors, in this case, a signal to the ESC that says increase the voltage, okay, increase your output to around 75%. And then that's when the motors spin up. So as I make adjustments, that electronic speed controls what's actually controlling the motors. And then depending on the software, if there's some stability in there, is electronic speed control. If it has some gyros in it and some inertial measurement units, IMUs, so in other words, says this is level, it's going to help me level it, is it will also send signals through to the electronic speed controls in order for the motors to either speed up or slow down in order to make the aircraft do what it wants to do. So that's how it works on a quadcopter. So what I've got is some different speed controls. I actually have some sitting on my desk. But the ones typically that you will see for this, in the upper left-hand corner, there is a Turnigy, and they call it plus 30 amp. So it's really important to see the amperage rating on your electronic speed controls. So if my output on my motor, so in other words, if my motor at max power needs 40 amps, I should have at least, a 40 amp plus a little bit more. I should probably have about a 50 amp electronic speed control, because this can only put out 30 amps. These things will get hot, and when you get to see these things inside, there's actually a little metal heat plate or dissipator plate in there to kind of cool down the electronics. But on this one, you can see, and I don't know if you can read that nomenclature or not, but this has a BEC in it, so it has a BEC. Let's see if I can switch over to the camera. And I don't know if this will focus. And it won't focus. All right. So let me go back to sharing my screen. Okay. So when you read this, so it's got a battery eliminator circuit, so it puts out 5 volts, and then the amperage rating. So it will put out 2 amps. So we have to make sure that all the equipment that we put on it won't draw more than 2 amps. The same thing is this one will probably support about a motor that at full power will use about 25 amps. So we got a little bit of cushion in there. And then the other thing that's important is down on the bottom. So it says it's good for DC, which is 5.6 volts all the way up to 16.8. So this one will support from about a 2-cell battery, okay, all the way up to a 4-cell battery. So if I plug this into a 6-cell, it's not rated for it, it'll probably burn it up. In the lower left there, you can see the red and the black wires coming out. So this is where you'd go directly, either if I was flying a fixed wing aircraft, that's where it'd go directly into a plug, which I'd plug into the battery, so the positive and minus. Or if I was going to fly something with a power distribution board like a quadcopter, then I would put the red on the positive and the black on one of the negative, the negative pads in there, and that's where this will get its power. And let me see if I can switch back to camera again and see if this will work. And so there's the bottom two wires that I was talking about, was the red and black, either go into a plug that goes into our battery for a fixed wing or onto a pad for a power distribution board. And then this wire that's coming off will go either into our flight controller, which is our autopilot system, or it will go directly into the receiver. And on a fixed wing aircraft, typically we use channel 3, and we're going to cover this when we talk about transmitters. We use channel 3 for the throttle, but when I make those throttle inputs, this is the wire that the signal goes through. Now, if I also have a battery eliminator circuit, is you notice that I also have, in this case, I don't think you can see it, there's a black, a red, and a white. The black wire is negative. Since I have a BEC, there's 5 volts of power coming through that red wire, and my signal wire for my ESC comes through the white. So that's how this thing is configured. If you look in the upper right hand corner, there's what they call a 4-in-1 ESC. So it's very hard to find these. I love these things. We used them early on, and they just don't make them anymore. But literally what it is the electronics for 4 separate electronic speed controls are embedded in that case. So instead of having 4 separate, one for each motor, I would just have one of these. You notice the wires coming off, there's a black and a red wire. That would go to either that would go to a plug, because there is no power distribution board. That would go right into a plug. It would plug into your battery. And then you notice there's signal wires coming off. And I'm not going to go into too much detail, but if you see around the perimeter there where it says M1, M4, M2, and M3, those are separate ESCs that would go to your motors. So one of the benefits is everything's encapsulated in one. I don't have to have 4 separate ESCs. The downside is if one of these ESCs goes bad, then the whole 4-in-1 ESC could go bad. Looking in the bottom left is you'll run across this quite a bit in racing drones. So I think these are 30 by 30 millimeter holes. So these are fairly standard, but this is an example of a power distribution board that also has your electronic speed controls built into it, or your autopilot module. So if you notice around the perimeter, same thing, as it has M1, M2, M3, and M4, and it's got a plus and a minus, but that will allow the power to go out. So it's incorporated into just a very small board instead of 4 individuals. And then the last one is down there in the lower right. You'll notice that is a 100 amp electronic speed control. So, and you notice it has a BEC. It says Super BEC on it, so it puts out 10 amps. And that one will handle from 2 amps to 6 amps. But a little bit different on that, if you notice, it's got heat dissipation, those cooling fins in there. So typically you'll see these on larger aircraft. So so this one right here, let me turn on some overhead lights. We had some students several years ago, they were working on the Flying Pancake. It's still in the back, but this is a 100 amp ESC that they got for it. It's pretty large, but it will handle a lot. The interesting on this thing is it had, typically you will find out when you plug in your battery to your electronics, is a lot of times you'll hear a pop. And that pop is an arc of basically a spark jumping from the battery to the connectors. If you notice this wire that goes across here, is that helps prevent that. So typically what I'll do is I'll plug this part in, I'll leave the red part off, and once it's powered up, then I can actually connect this, and it's a spark proof or spark resistant connection for that. Same thing as I've got a beck coming off, and I also have the cable for my speed controllers. And then I've got 3 pretty hefty, AC outputs that go into my motors. Okay. Hopefully that makes sense to everybody. Okay. All right. I am not an electronics expert by any means, but this is kind of how an electronic speed control works. So it takes, the power in, and in order to get a direct current to an alternating current, you'll see that it has those kind of gates up there. The circuitry in this, that drive circuitry and the rotor position circuitry, work together in order to basically move those gates in and out. So it only energizes one set of coils, or actually 2 sets of coils in the motor at any one time. And that's how it gets it to pulse. So what you will never see is that internal circuitry in here. Is you'll never see, 2 of them closed at the same time. So this is what drives basically the rotor on our electronic circuitry. And then on the bottom left, you can see how the beck, taps off and goes to the throttle, which picks up the signal. And then if need be, it actually powers our receiver. So, if you want to get more into this in electronics, I'm sure somebody can break it down for you, but that's pretty much, if you take this apart, you'll see a lot of circuitry, and that's what it does. Is this is how it takes that alternating or direct current and turns it into alternating current. Okay. The other thing is, I talked about a BEC, which is a battery eliminator circuit. Sometimes you will have an electronic speed control that doesn't have a BEC. Okay. Now, it will still have the cable to get the signal, from the receiver on what to do with the throttle, on how to control it, but it doesn't provide 5 volts. If that's the case, what you need is they actually make separate BECs, battery eliminator circuits, and their only job is to take whatever the DC power is available, and depending on their rating, typically it's from 2 cell to 6 cell, but we'll take that voltage and basically step it down to 5 volts. So if you look at this example on this 10 amp BEC, it's good to 6S. It will do anywhere from 4.8 to 4.9 volts out, so it's actually adjustable. So I can adjust this. And in this case, you notice that because the ESC does not have a BEC in it, my receiver will not get power. So in this case, I have to tap off that battery using this BEC in order to get 5 volts into my receiver to power it. So hopefully that makes sense. The other time I've used a BEC is we've run some 6 cell batteries, and the power that I needed to run either the gimbal or the sensor on the aircraft had to be, I think the max was 3 volts. For that. So one of our sensors only takes 3 volts. So what I had to do is get a BEC that stepped down that 6 cell, 6 cell voltage from 24 or whatever it is down to 3 volts. And so I tied that into the battery, the BEC stepped it down, and then I fed that into our sensor. So sometimes you got to use BEC separately to power electronics. All right, the other thing is, this is the last thing, is most ESCs, electronic speed controls, are programmable. So if you've ever plugged in an ESC and you hear those musical tones, that is basically the startup feature of an ESC. The other thing is we can calibrate this ESC to do different things, and I'm not going to go through everything, but we can do it a couple ways. Um, and typically what we use is, if you look up on the left there where it says program mode audible tones, um, for a throttle calibration. So if we take our transmitter, and we'll talk about this later on transmitters, if I take my transmitter, turn it on, and I take the throttle and put it all the way up, okay, so basically full throttle, and then I plug in my aircraft, when the ESC through the receiver senses that it is all the way up, that is telling it to go into a programmable mode. And then all those beeps or musical tones are that we can set in order to what we want to do. And I know that doesn't make sense, but if I have an aircraft, I built the aircraft. So when you build your first aircraft in the box quad, is that ESC is kind of factory set to basically a high to low function. So it's going to be the lowest throttle setting to the highest, but that may not correspond to my transmitter. So that transmitter, so in other words, if I go all the way up on my transmitter, so I want full power based on the way the ESC is calibrated, is we may only get 80%, 85%. So what we have to do is calibrate that ESC to the transmitter throttle range. And so to do that, and everybody has a little bit different, you have to read the manufacturer on the ESC how to do it, but typically you start the transmitter, put the throttle all the way up, then plug in the ESC, and then after you hear those 4 beeps, you'll hear a beep, 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 beep. You take the throttle and put it all the way to idle, and then you'll hear another series of beeps, and then it's programmed, and then you unplugged it. So what we did was we actually calibrated that ESC. So sometimes that can get confusing. You can see we can set the ESCs have brakes on them, okay, and not the kind of brakes that you're thinking of. But let's say that is when I'm coming into land on a fixed wing aircraft, is I don't want my propeller windmilling. So my throttle's at idle. I don't want that propeller windmilling. Is I can set a brake to turn it on or off. In this case, I want to turn it on. So when I bring that throttle to idle, what it does, it freezes that motor. Okay, so it stops it exactly where it's at. So I can turn that on. You look at number 2 there, we can, program NICAD or LiPo. The other one that we need, sometimes you got to be careful of, is this low voltage cutoff threshold. So you can set it either low, medium, or high. This is primarily used for fixed wing aircraft. Okay. So on a fixed wing aircraft, if your battery gets too low, so you're getting down there, you've used it quite a bit, it's getting low, you can program this shutoff, is that when it hits that criteria, that limit that you set, is that it will actually stop the motor. I won't say stop, it will stop providing power to the motor in an effort to protect your other electronics. So if I'm flying a fixed wing aircraft, I'm flying along and my battery gets too low and everything dies, not only do I lose the motor, but I lose my receiver, I also lose my servos. And now the thing is just going to take off in whatever direction. It's become a brick heading in that direction. As opposed to if I set a low voltage cutoff, is when it gets to that voltage, is the aircraft motor will stop, okay, which is sometimes not a good thing. But now at least it will be a glider, but I still have controls to my ailerons, my elevator, and my rudder, and whatever else that I need, and also to my receiver, in order for me to try to dead stick that down. Okay, what else? We got some other settings there. So we can either do it by beeps, and sometimes doing it by beeps is tough. It can be a challenge. The other thing you can do is over on the right-hand side is kind of a drawing of what they call a ESC programming card. But we can actually plug this into the ESC and a power source, and we can use this card to push buttons to actually turn things on or turn things off. So instead of listening to the beeps, is those little buttons that you see there with the white within the red circles will actually light up. and we can use the buttons down on the bottom to actually program it. So makes it a little bit easier. So that's all I have on electronic speed control. So, we talked about batteries, we talked about the different type of motors. So this week, go through and look at the videos that are in the learning activities in the D2L. And then, like I said, is the quiz on batteries, motors, and ESCs will be available starting tomorrow. So that's all I have. Let me get out of here. Anybody got anything?
So I've been wondering for a while, and I haven't been able to find a lot online about this, but when I was younger, I did a lot of stuff with like RC planes and helicopters and stuff like that, and they all used DC motors. Beyond having the ESC help with that, and I guess that's a bit of a. Anyways, why DC motor or AC motors now instead of DC motors?
So the difference between what we're using now and what we used to use, and you'll still find the DC motors, but they're called brush motors. Right. Is that on? Let me get this over here. AC motors are a little bit more efficient, and so on a brush motor, you have actually brushes that can wear out, and they're not as efficient. So you can tell an ESC for a brushless motor because it's got 2 wires, a red and a black, going in, but it has 3 wires coming out. Okay, and that's where we get that 3-phase alternating current, as opposed to an ESC. So even a brush motor uses an ESC, but you've got 2 wires coming in, which is your black and your red, your positive and your negative, and it's only got 2 wires going out, and that goes to a brush motor, and you can't interchange these. Does that make sense?
Yeah, it's just yeah. I guess I didn't imagine that they would be more efficient because you'd have to do all those conversions, and I'd figure you'd lose enough of the energy converting it to AC to make it not worth it.
Well, it's, yeah, however they do it. Let's see, brush. Let's see if I can find a good. Yep. Let's see, brushless motors versus brush. Let's see if we can find a good image here. Yeah, I don't really see one, but you can hang on here. Yeah, no, they're just more efficient. I was going to see if I can find a good diagram that talked about them, but they both use ESC. So the ESC works pretty much the same, except on a brush motor is it doesn't convert it to alternating current, but it still uses that wire that comes off the signal wire to control the output. So let's see. Let me bring this up. So if you look here on a brushless DC motor, let's see, based on Hall, I don't care about. So maintenance on a brushless DC motor.
Mm-hmm.
So this is a brushless motor on a DC. So there's less or no maintenance. On a brushed DC motor, there's maintenance. The lives are longer because you don't have brushes to wear out. That was the other thing is the brushless AC motors can actually provide more torque.
That makes sense. Yeah.
And then the efficiency on a brushless motor is higher than a brushed. Same with the speed range. So one reason they can put out more torque or higher RPM is there's limitations on those brushes. They got some stuff on noise there, but yeah, so a little variation in efficiencies. So, but that answer your question?
Yes, sir. Got it.
Okay. And anybody else? Going once, going twice. So hopefully everybody's doing okay. Like I said, if you've got any issues, let me know. Like I said, I'll be putting this up on YouTube here shortly. Actually, I've got another meeting here in about 40 minutes for another class, but I'll be doing that. But you keep in contact. If anything, if anybody's having any issues, please let me know. So anyway, that's all I got, unless somebody has anything. If not, we will talk to you next week. And just remember, quiz is opening tomorrow. So, all right, everybody have a good week. Talk to you later.